Hello everyone, I am Prem Kumar. Welcome to Olympiads Math Academy. So today I am going to discuss with you a very interesting topic, some modulo arithmetic. You know that is congruence modulo m. M is any positive integer, right? So what is that meaning? How we can apply in the number theory problem, and this complete idea we can discuss today. Okay. First, you can see A congruent to B modulo M. What is the meaning actually? Reminder, this is your, this is the meaning, right? Divisor. So this is, okay, that means A divided by M, you will get the remainder is B. That means when you take A, when you divide by M, and you will get the remainder B, both will be remainder and the dividend should be identical here. So when you divided both of them, it would be same, right? So four, five, six. Okay. Yes, good. You can see, just 1 minute. Let's take here is, once you see this clock, you can see the railway time. After 12, you can see they will say 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, right? After, you can see 12 o'clock, you can see the here is afternoon, you can see 13. They had to use 13. 13 is congruent to 12. 12 hour is there, no? 13 and 1 will be same, identical. That means what? When you take 13 divided by 12, 1 time 12, this will be remainder is 1. That 1 and 13 will be same. Clear? Okay, so what is the meaning another way? Using the divisibility idea you can say here. So, see, this meaning is 12 divides 13 minus 1. That's the meaning. That means 12 divides 12, right? It is true, right? First, you have to understand what is A divides B. A divides B means A is the divisor, B is the dividend, right? That meaning is B divided by A. That's the meaning. Divisor is A, B is the dividend. If that means if A divides B means the remainder would be 0, right? Let's take here 2 divides 4, right? So when you 4 is divided by 2, 2 times 2 it is 4, remainder is 0. Clear? So the number is completely divides means the remainder is 0, right? Let us take 2 does not divides 3, right? Because you can get 1 times 2, the remainder is 1. So it is not completely divides, right? Okay. So how to write in mathematically? A divides B means there exists a integer, let us take n belongs to integer such that B is equal to A times n. The remainder is completely 0 here. So here A is the divisor, n is the quotient here. Understand? The plus remainder is 0. Understand? For example, if I take 2 divides 4 means 4 you can write as, how to write 4? Dividends equal to divisor 2, quotient is you can write 2. 2 into 2 only 4. Clear? Let us take 6 divides 12, right? This is how to write. 12 is equal to 6 into 2 you can write. Understand? Way you can see, if I take A congruent to B modulo M, what is the meaning? M divides A minus P, the difference of the dividend and remainder. What is the meaning actually? There exists n belongs to integer such that what? You already know that A divides means what? I can find n belongs to natural number such that B is equal to A times n. The same way, there exists n belongs to integer such that A minus B is equal to A times, sorry, what to write? A minus B is equal to m times n you can write. Understand? Okay. I hope everyone understands this one, right? Okay. Let me take the first thing. A congruent to A modulo m. This is the first property you can see. How to prove this one? You can see the first one by definition is what? A congruent to A modulo m means what? M divides A minus B. The same way, A congruent to A modulo m means m divides A minus A. This implies m divides 0. Correct? Because any number you can take, 0 is actually what? You can able to divide, no? 0 divided by m, m may be any. Clear or not? M divides 0. So therefore A is congruent to A modulo m. Understand? Because 0 by any number you can take, right? 0 only, right? It is completely divides, right? Therefore A congruent to A modulo m. So any number you take, it is congruent to itself. Understand? Next you can see A congruent to B modulo m, congruent to A modulo m. How to prove this? Very simple. How to take? So A congruent to B modulo m means what? M divides A minus B, right? Okay. This implies what? There exists K belongs to integer such that A minus B is equal to m times K you can write. Clear? But you have to say that B congruent to A modulo m. That means you have to say m divides B minus A. You have to understand clearly. If A congruent to B modulo m means what? M should divides A minus B, the difference of the dividend and the remainder. The same way, you have to prove that the commutative m divides B minus A means what? M congruent to A modulo m means m divides B minus A. You have to prove it. But how to prove that? But you know that m divides A minus B is given to you. For example, if I take 2 divides 8 means 8 you can write as, so 2 into 4 you can write. This is your K here. Understand? Okay. So therefore A minus B is equal to m times K. M is the divisor, A minus B is the dividend, K is the quotient here. Okay. So if I take minus out, what will get? B minus A is equal to m times K. So therefore B minus A is equal to minus or m times minus K we can write. Minus K may be any integer, right? K is already integer. If you multiply minus, again it is integer only. So therefore from this what we can say? This is m times some K1 you can take. K1 is equal to minus K you consider. From this we can say B minus A is equal to m times K1 means from this we can say m divides B minus A. Clear? Just you can see 8 equal to 2 into should divide the dividend, correct? Understand the same idea. B minus A is equal to m times K1 means m should divide B minus A. From this what we can conclude? B is congruent to A modulo m. Understand? So all of you understand this one, right? Okay. Let's prove the third one. Third one you can see. Let us take another page. What is the another page is given to you? B modulo m and B congruent to, so what is the question here? Congruent to B modulo m, B congruent to C modulo m, then this is transitive, right? A congruent to C modulo M, you have to say. B congruent to C modulo M, then you can say A is congruent to C modulo M. How to prove this one? Third one you can see. So A congruent to B modulo M means what? M should divide A minus B. And same way, B congruent to C modulo M means what? M divides B minus C. Okay. The same way, you have to prove that. To prove what? To prove M divides A minus C, we have to prove. Clear? So you have to use this idea. How to connect this? So M divides A minus B means what? A minus B is equal to some M times some K1 you can take. Integer. The same way B M times some K2. K2 is belongs to integer we can write. But we need A minus C. So for that what you can do? You can add these two things. Second you take add 1 and 2. What will get? A minus B plus B minus C is equal to times K1 plus M times K2. Minus B plus C cancel. A minus C is equal. K is equal to where K is equal to K1 plus K2. Because K1 is integer, K2 also integer, the sum of integer is again integer. So A minus C congruent to M times K means what? We can say M divides. If you say 8 is equal to 4 into 2, you can say means, we can say what? 4 divides 8, right? 4 into 2, definitely 4 should divide 8. Understand? Because 8 dividends equal to divisor into quotient. Clear? Okay, from this what we can say? We proved no M divides A minus C. From this we can say A is congruent to C modulo M. We proved. Next thing you can see, what is the next proof? Next proof is what? Fourth one, A congruent to B, C congruent to D modulo M, then A plus C congruent to B plus D. Okay, A congruent to B modulo M, C congruent to D modulo M, then A plus C and AC we have to prove this, right? So, A congruent to B modulo M and C congruent to D modulo M. So to prove modulo M, this is the first point. Second one, I have to see here modulo M. Clear? So first one, how to prove this? Let me check once again it is correct or not. You can see. Yes. A plus C, AC and BD. AC and BD is correct. You can see here, student. First one, how to prove this? A. Okay. And C congruent to D modulo M. So already is there, right? It's given to you. By definition, M divides A minus D. And the same way, M divides C minus D you can write. Clear? So what is the meaning? M divides A minus B is equal to some M times K1 you take. K1 belongs to integer you can take. The same way, C minus D is equal to M times some K2. K2 is belongs to integer you can take. The same idea, right? We already discussed this. From this, how you can say that A plus C is congruent to B plus D? So you can see, if I take this one, A plus C is congruent to means what actually required M divides A plus C minus B plus D, you can say, right? Correct or not? If you add these two things, what will get? Plus C minus D is equal to M times K, M times K2. Let's take this is 1, this is 2, you can take, and so you can see A plus C first and third you can combine. A, you take B plus D is equal to M. If you take K1 plus K2, you can write. Clear? So from this we can say that M times, this is, let us take some K, where K is equal to, what? K1 plus K2 you can write. So therefore from here A plus C minus B plus D is equal to M times K. So from this what we can conclude? From this we can say M divides A plus C minus B plus D. From this we can say that A plus C is congruent to B plus D modulo M. Clear? I hope everyone understand. Just use the definition, that's it, right? Okay. Next one you can see. Next one, what we can do here? Yes. AC is congruent to BD modulo M. That means M divides AC minus BD, right? You have to prove this one. Okay. So, but you know that A, already know that what is A. From this you can see 1, you can see from 1. From 1 we can say A is equal to, that minus B is sent to the right side. So, B plus M times K1 you can write. The same way from 2 we can say C is equal to D plus M times K2 you can write. Clear? Okay. So from this what we can conclude here, A, C we require, no, you multiply these two things. So multiply 1 and multiply 2, what will get? AC is congruent, sorry, AC is equal to B plus M times K1 into D plus M times K2, right? If you multiply this, BD plus B into M times K2, just I multiply M times K1D plus M times M square times, right? K1 and K2, right? So AC here, AC is equal to BD. You can see what actually we need to prove is M divides AC minus BD. Okay, this BD you can send this left side, right? You can see what you can do. This plus BD you send this left side. Okay, M you can take it out. What is left actually? M, if you take B times K2 plus, you can see then here is K1 times D plus M times, here is K1, K2. Clear? So whatever it means, it's integers, completely integers, right? This is completely integers. From this, let us take M times some K you can take. K is this portions, right? So therefore, AC minus BD is equal to M times K, means M divides AC minus BD you can say, right? I hope you everyone understand. Just you multiply these things, you will get it, right? Okay, next thing you can see. What is the next one? Okay, so next one you can see A congruent to B, then A plus C is congruent to B plus C modulo M. So this one, how to prove this? I will prove here only. You can see. So A congruent to B modulo M means what? M divides A congruent to B modulo M means, you can see here, M divides A minus B. Okay. Okay. Then how to say that A plus C? So you can see when you take M divides, you can see A plus C, you can add and subtract plus C. So add C and subtracting plus minus C, right? Subtracting C. So what will get? Minus C minus B you'll get, right? So from this, there is no changes, right? M divides, what we can say? A plus C minus, you can say B plus C we can write. Understand? I'm adding C and subtracting C, right? So from this, what we can say? A plus C minus B plus C is there, right? So from this we can say A plus C is congruent to B plus C modulo M, we can say, right? Clear? So some integers C here, you can add it both sides, right? It will not be changed. So we prove this one. You take any number, you can add and subtract it. There is no changes in the divisibility, right? I hope everyone understand, right? Okay. Let's do the next one. You can see next one is what? A congruent to B modulo M, then A power K is congruent to B power K for all K is greater than 1, right? How to prove this one? So let me take, you know that, what is the meaning actually? M divides A power K minus B power K, right? That's the meaning, right? For all K greater than or equal to 1. You can see, student, how to prove this one. You can see A is congruent to B is there. Okay. So what is the meaning actually? M divides A minus B is there. But you know that A power K minus B power K, you know the formula? A minus B into A power K minus 1, because A into A power K minus 1 is what? Base are same, adding the power. K minus 1 plus 1 is K into B power 0, A power K minus 2, B power 1, so on, A power 0, B power K minus 1, right? This is the expansion, right? So from this, we can say M divides A minus B means, so definitely M divide A power K minus B power K also. For example, if I take 8 is equal to 4 into 2, you can write. Definitely, the 4 should be is a factor of 8 and 2 should be factor of 8, right? Understand? So, correct or not? Definitely, so M divides A minus B means we can say that M divides A power K minus. Clear? Understand? M is dividing this one means definitely it should divide this also, because this is, you can write the product of two expressions. Understand? From this we can say that A power K is congruent to B power K modulo M, we can say. So for this is for all positive natural number, K is all greater than or equal to 1, it is true. You can raise that number, there is no changes, right? Okay. For example, if I take 2 is congruent to 1 modulo, what is that? So if I take 3, it's minus 1, right? 2 is congruent to minus 1 modulo 3, correct? Because why it is true? Because 3 divides 2 minus of minus 1. That is 3 divides 3. It is true, right? So when you rise power, that means more than 1 you can take, equal to 1 or more than 1. You can rise 2, 2 square is congruent to 1 modulo 3. So 2 square is what? Okay. So this is, I hope everyone understand this one. Okay, next you can see, what is that? A, B, C belongs to integers such that AC is congruent to BC modulo M, and then GCD of C and M would be D, then A congruent to B, D is there, right? Okay. So how to prove this one? First, you have to understand this clearly. Let us take here, D is given to you, GCD of C and M. Okay, let me take this one quickly. What is the page? AC congruent to BC modulo M, right? AC is congruent to BC modulo M is given to you, and then what else given to you? You can see here, yes, AC congruent to BC modulo M is given, M is greater than 0, GCD of C and M is D, GCD of C and M, GCD of C and M is D. What actually we need to prove? What actually we need to prove here? A is congruent to B modulo M by it, right? This one, okay. A congruent to B modulo M by D. Congruent to B modulo M by D. Hello student, we'll continue this today. Again, this one, you can see student, AC congruent BC modulo M and GCD of C and M is D, then prove that A is congruent to B modulo M by D. We have to say this. D is the greatest common divisor of C and M here. Okay. You can check it again. The question you can see. The question is what? CE here is any integer, A, B, C are any integers, right? And M is greater than 0, right? You have to prove this one quickly. How to prove this? AC is, right? This is one side. Means what? D should divide C and D should divide M. Clear? Because you can see here the GCD of 2 and 4 you can take. The common divisor is what? So 2 only, right? 2 is must divides both the numbers. So greatest would be 2. That means 2 should divides 2 and 2 should divides 4 also. So greatest common divisor always divides both the number, right? So from this definition you can use, there exists k1 you can take, belongs to integer, C is equal to D times k1 you can write. The same way there exists k2 belongs to integer, we can say, what we can say, M is equal to D times k2 you can write. Clear? Okay, so therefore here M by D is equal to k2 you can write. Okay, so fine. So what is given to you? A to BC modulo M is given to you. That means M divides AC minus BC by definition. So the but you know that property says if A divides BC and GCD of A and C are 1, then you can say A divides B, correct? You know this divisibility rule, the G, you can say A should divides B, right? Let us take one example. 2 divides, so 3 into 2 you can say, right? This is 6, right? So you can see 2 and 3 is 2 and 3 are relatively prime. The HCF of this will be 1. Otherwise, GCD of 2 and 3 is what? 1, right? Then you can say 2 divides 2. Clear? Okay, the same way. So here C is what? D is given, right? Given. Then you can say that it is given that it is D. So definitely it should, M should divides A minus B, right? Clear? So therefore A minus B is equal to, we can say, M times some K, right? Otherwise, what we can say here, otherwise you do one thing, you can see, C is what actually? D times K1, A minus B is there. Definitely you can see, you can divide it by D both side, what will get? So M by D divides K1 into A minus. What is M by D here? M by D already know that K2. K2 divides K1 into A minus B. But you know that this property A divides BC, A and C are relatively prime, then you can say A divides B. So you can say here K2 and K1 here is the relatively prime. So we can say that K2 should divides A minus B, right? K2 should divides, 1 minute, K2 should divides A minus B, because you can see the K1 and K2 are relatively prime. Here you can take here, right? K1 and K2 are relatively prime, you can say. So then you can say that K2 divides, so you have to remember, some A divides the product of two number means that A should divides other number. The same way here K1, K2 are any integers here. So K2 divides the product of K1 and A minus B means the K1 and K2 are relatively prime. GCD of K1 and K2 is equal to 1. We can say that K2 should divides the other number A minus B. Clear? From this we can conclude that, so K2 divides A minus B means A minus B is, how to write it? How to write this one? A is congruent to, so K2 is the divisor here. A is congruent to B modulo K2. Clear? Understand? So therefore A is congruent to B. What is modulo K2 is what? K2 here is what? M by D, right? M by D. Clear? I hope everyone understand, right? Okay. We prove this one also. The next you can see, what is that? Next one you can see here. What is the next one? Is we prove this one, no? Okay. Yes, you can see the next, you can see the note. Is ABC is belongs to integer, AC is congruent to BC modulo M. M or relatively prime or GCD is 1, then A congruent to B modulo M. You have to remember this. AC is congruent to BC modulo M, C and M are relatively prime. That means the HCF or GCD of C and M will be 1. Then you can say that it's a cancellation property. C and cancel it. Then A congruent to B modulo M you can say. But you can see if AC congruent to BC modulo P is any prime, then P does not divide C means, then you can say that A is congruent to B modulo P. So you can take any prime number you can take. If the prime number is not a factor of the C, then you can say that A is congruent to B modulo P. P is any prime number you can take, right? Okay. Now let us discuss the questions. Okay. Next, before going to discuss the question, you have to understand some ideas. 7 is congruent to modulo 8. When it divided by 7, the modulo 8 means the minus 1 is the remainder. Why it is true? Because you can see the reverse one, right? So otherwise you can see the definition 8 divides 7 minus of minus 1. 7 plus 1 is 8. It is true. Okay. Let us take second one. When you divided by modulo 12 hours, you know what is the railway time? 22. When you divide by 12, 2 times 12 is what? 24. But when you take 1 time, 12 is what? 12. The 10 is the remainder. Okay. So when you write in the negative remainder, how to say this? -12 we can say, right? -2 also we can say. So why it is true? Because 22 minus of -2, that is 12 divides 22, that is 24. 12 divides 24, right? Yes, true. So let me take so 2 power, let us take 50. So when you take is so divided by, let us take 3, right? So 2 power 50, when you divide by 3, what is the remainder? So you can see, first you have to, very simple thing is, you have to take 1 or -1, the remainder, the possibility you can try, right? So 2 is congruent to modulo 3 means, so -1, right? Why? Because 3, right? Okay, fine. So when you take this one, we already discussed this, A congruent to B modulo M, then A power K is congruent to B power K modulo M, when K is greater than or equal to 1. So which number you have to raise it here, you will get a 50. 2 power 50 you can raise directly, -1 to the power 50 modulo 3. Clear? So therefore 2 power 50 is congruent to -1 power 50 is what? 1. It is even power modulo 3. I hope everyone understand, right? Let's do the more questions. You can see this question is here. You can see the show that 41 divides 2 power 20 minus 1. Show that 41 divides 2 power 20 minus 1. How to check the students? Show that 2 power 20 minus 1. You can see student 41 is there, no? So 2 power 20 is there. You can see 2 power 5 is what? 2 power 5, 2 power 4 is 16, right? 2 power 5 is 32, right? So I am taking this 2 power 5, if you take, if you rising the 4, so you will get 2 power 20, right? So you can see 2 power 5 is, right? The divisor here is what? 41, right? So when you divide it by 41, so what is the remainder you will get? 1. you can see here, if you add 8, it is 49. 9 you'll get, right? So minus 9 you get, right? Understand this one? Okay. Because 32, 41 divides 32 minus 9 will minus of minus 9, it's a 41, right? Therefore, need 2 power 20 is required. Is congruent to minus 9 whole below 41. So, you know that minus 9 whole square you can write. This is minus 9 modulo 41, right? So, this is same as what? 2 power 20 is congruent to minus 9 square is what? 81 into 81 is modulo 41, right? So 81 when you divided by, because 81 is congruent, no? So when you divided by, because these two are identical, 2 power 20 is congruent to 81 only, no? So 81, when you 81 into 81 is the identical, right? When you 81 divided by 41, what is the remainder? So 80, so 41 into 2 is what? 82. So you can see minus 1 is the remainder, right? So here is 81 divided by 41. So modulo 41. Clear? 1 into minus 1. To understand, 81 is congruent to modulo 41. 2 times 41 is what? 82. But here 81 is, you can see this will be minus 1. Why it is true? Because 41 divides 81 minus of minus 1 by definition. 41. So 41 divides 82, correct? 2 times 41 is 82, right? Okay, it's true. Therefore, 1 modulo 41 we can write. This is 2 power 20 we can say. So from this we can say that 2 power 20 minus 1 is congruent to 0 modulo 41. So if remainder is 0, definitely we can say that 41 divides 2 power 20 minus 1. Clear? Let's do the next question. What is the next question you can see? So, it is that next question. Find the remainder. 5 power 48 is divided by 24. 5 power 48. 5 power 48 divided by 24. 5 power 48 when you divide by 24. What is the remainder? That is only they're asking, right? Okay, how to do this? You can see the 5 power 48 when you divided by 24, what is the remainder? They're asking. Very nearest to 24, you can see 5 divided by 24. So you'll get 1. 24 when you divide by 24, the remainder is 1, right? Okay. So when you multiply by 20, it is 40. 24 is, if you multiply, what will get? 24 into 2 is what? 48, right? Yes. To rise 24 is congruent to 1 power 24 is modulo 24, right? I hope everyone understand, right? So, to 1 modulo 24. So what is the remainder here? When you take 5 power 48, when you divide by 24, the remainder is 1. Your remainder. Clear? Okay. Let me take another problem. Okay. Okay, next question you can see. What is that? So find the remainder when s is equal to 1 factorial plus 2 factorial, 3 factorial up to 1000 factorial divided by 8. You can see the next question you can see 1 factorial S is equal to 1 factorial, 2 factorial, 3 factorial plus 4 factorial, so on up to 1000 factorial, right? So when you divided by modulo 8, what is the remainder they're asking, right? But you know that minus 2 up to 1, right? So 4 factorial means what? 4 into 3 into 2 into 1. You can see 4 into 2 is 8. So definitely when you divide it by 8, the factor is there. So therefore remainder will be 0, right? So when you take 3, sorry, 4 into 2, again it is 8 is there, right? When you take 6 factorial, 6 into 5 into 4 into 1, the same way here 4 into 2 is there. So 8 is the factor is there. So definitely if you take a 4 or more than 4, the remainder will be 0. Therefore, when you divided by, so S is what actually 1 factorial plus 2 factorial plus 3 factorial, remaining everything will be 0 because each term 8 is there. When you divide by 8, the factor is, it is a factor, therefore remainder will be 0. So modulo 8. So therefore S is congruent to, so 1 here is 1, 2 factorial is 2, 3 factorial is what? 3 into 2, it is 6 modulo 8. So therefore S is congruent to 8 plus 1, it is 9 modulo 8. Clear? I hope everyone understand, right? So 8 plus 1 is 9. 9 divided by 8, it is 1. So modulo 8. So the 1 is the remainder. I hope everyone understand, right? Okay, let's do the next question. You can see. What is the next question? Okay, you can see that find the remainder 2 power 24 is divided by 17. How to say this one? Find the remainder. 2 power 24 when you divide by 17. 2 power 24. 2 power 24, right? 2 power 24 divided by 17. You can see what is the meaning? Modulo 17, right? So which is very nearest to number? 2 power 4 you can take, it is 16, right? So 2 into 2 into is congruent to modulo 17 you can take, very nearest to that. Okay, this is same as what? 16 when you divide by 17, you can see the difference, you can see minus 1 is required, right? So minus 1 is there, right? Because 16 minus of minus 1, it is 17. 17 divides 17. Therefore, the remainder is required. You have to raise the, which number you have to raise? 2 power 4 is there. So you have to raise 6, right? 2 power 24, right? So minus 1 to the power 6 modulo 17. So that power here. So 1 modulo 17. I hope everyone understand, right? Okay, fine. Next, you can see the next question. What is the next question? Yes. Prove that there are infinitely many natural number n such that n square plus 1 is congruent to modulo 5. N square plus 1 congruent to modulo 5. N square plus 1, right? You can see n square plus 1 is congruent to modulo 5. Correct? You can check it once again. What is the question? N square plus 1 is congruent to 0 modulo 5. So there are infinitely many n, you have to prove that, right? Congruent to, so you can see the congruent to 0 modulo 5. That means what? N square is congruent to minus 1 modulo 4. modulo 5, sorry, modulo 5. But you can see minus 1, it is 5 is there. Equivalently, how to write? 4 modulo 5, you can see. Check it correct or not. Let's see, minus 1 is congruent to 4 modulo 5 or not. Yes, it's true. Right? Correct. Okay. So understand, therefore, minus 1 is congruent to, 4 modulo 5, you can say, right? So when you take n is congruent to 4 modulo 5 is there. So which are the number you can take here? 0, n is equal to, you can take, so n modulo 5 and n square modulo 5, you can see. Which one is possible? 0 if you take, 0 square is what? 0 square is 0, modulo 5 will be 0 only. When you take 1, 1 square is 1, modulo 5 will be 1. If less than 5 is there, when you divide, let's take 2, 2 square is what? 4. You can say minus 1 or 4, you can say, right? But both will be same only. Minus 1 is identical. Let us take 3, 3 square is 9. 9, when you divide it by 5, the remainder is 4. Let's take 4, you can take. 4 square is 16. When you 16 is divided by 5, so the remainder is what? 1, right? Yes, remainder is 1. Let us take 5. 5 square is 25. 25, when you divide by 5, what is that? 25, its remainder is 0. Right? So you can see any number you can take. So we have the number is 2 and 3 only is congruent. So therefore you can take n is congruent to 2 modulo 5, 3 modulo 5. Any n you take, so any n you take is congruent to 2 modulo 5 or n is congruent to 3 modulo 5, you can take. The n square will be what? N square 4 modulo 5, you can say. Therefore we can say there are infinitely many prime number is there, many numbers, infinitely many numbers such that n is congruent to 2 modulo 5 or n is congruent to 3 modulo 5. If this kind of situation is there, no? So this kind of n will be satisfied. Therefore, there are infinitely many n possible, right? There are infinitely many number n, right? Infinitely many number n is possible here. We need to prove that only, right? You can check it once here. We had to prove that there are infinitely many natural number. N here is a natural number such that n square plus 1 is congruent to 0 modulo 5. N square is congruent to minus 1, minus 1 is congruent to 4 modulo 5. So you have to say that square will be congruent to 4. Which are the number is possible? N is congruent to 2 modulo 5, right? And 3 modulo 5. Such kind of number you can take. You can square will be is congruent to 4 is possible, right? Understand? Okay, so we'll discuss the next one. You can see what is the next question? You can see that we'll discuss the Chinese remainder theorem. Chinese remainder theorem, very important theorem. You can see what is this Chinese n1, n2, n3, nk or pairwise co-prime integer. Co-prime, if you take any GCD of ni and nj, I not equal j, they are relatively prime. So we are given a system of congruence. So we need to find the system having this kind of system. You need to find the unique solutions, right? So find x such that it satisfies all the congruency, right? X is congruent to a1 modulo n1, x congruent to A2 modulo N2. The same way x congruent to AK modulo NK. There exists a unique solution modulo N is equal to the product of all the NK. So how to find out the suitable x value here? You can find the unique solution satisfies all the congruency. If you have some x value that satisfies all the congruency modulo different n different a satisfied, this is your Chinese remainder theorem. If you have system of equations, how to solve the solutions uniquely, you can use this Chinese remainder theorem. Clear? Okay, then I will take one example here. X is congruent to 2 modulo 3, x congruent to 3 modulo 4, x congruent to 1 modulo 5. You need to find the unique solutions x, find out n. N here is what? What is n? N1 into N2 into N3. So here N1 is what? 3, N2 is 4, N3 is 5. What is A1? A1 is 2, A2 here is 3, A3 here is 1. Right? So first you need to find out the N1. How you can find out? So first you have to understand what is the product of all the ni's, small ni's, right? 3 into 4 into 5. How much it will be? 60, right? So first step is you have to find the product of all the ni's, that will be n. So you need to find the x congruent to modulo 60. You need to find out for the unique solutions, right? For that, n divided by n1, that you can consider n1, right? So what is n here? Capital N, 20. The same way n2, that capital N is what? 60, small n, n4, right? 15, right? The same idea you can find out n3, n divided by small n3, you can see 60 divided by 5, right? Is it correct? Yes, 12 times is possible. So next step is how to find out x here. You need to find the inverse of each ni, you have to find out, right? Next step is what? Find the inverse of each ni's modulo ni's. You have to calculate, right? Okay, this is the procedures for the Chinese remainder theorem, right? How to find out that? So what is ni here? 20, first one. Let us take the inverse here is y1, right? There exists a y1 such that 20 y1 is congruent to 1 modulo. What is n1 here is 3. Okay. So this is the inverse. How to find the inverse of that? 20 something you can multiply, you get remainder is 1. That is the inverse of that. Suppose 2 is there, multiple of multiplicative inverse is what? 1 by 2. That should be 1, right? The same idea here. 20, you have to find the inverse of each ni. Ni here is 20, 15, 20. Sorry, 12. So y1, there exists y1 such that 20 into y1 is congruent to 1 modulo 3. So which y1 is possible? But you know that 20 is congruent to, when you modulo 3, so which number is possible? Congruent to. Let us take, so 6 times 3 is what? So when you take 20, when you divide by 3, the remainder is 2. The 20 is congruent to 2 modulo 3, you can write. But the same way, these two are identical, means you have to replace 20 is there, no, you replace 2. 2y1 is congruent to 1 modulo 3, you can write. Clear? Because which number you have to take y1 such that when you divide by 3, you will get 1. If I take 1, so 2 divided by 3, you will not get 1. Yes, possible. Let us take 2 into 2, it is 4. 4 divided by 3 is 1, possible. Therefore, suitable y1 here is what? 2. I hope everyone understand, right? Let's do the second one. What is second one? Here is N2, right? So N2 is 50. Second one is what? 15 Y2 is congruent to 1 modulo, which is your N2 is 4, right? You have to take 4. Okay. So which Y2 you have to find out here? But you know that 15 is congruent to, how to write 15 when you divide by 4, 3 times 4 is what? 12, the remainder is 3, right? So 3 modulo 4. To 1 modulo 4 you can write, because 3 and 15s are identical. You can replace it. For Y2 such that product will be, when you divide by 4 you'll get 1. Which number you take? Let us take 1. It's not possible. Let us take 2. 3 into 2. 1 is possible or not? 2 here. So 3 into 2 is 6. 6 divided by 4 is not 1. Right? Is it correct or not? Yes. Let us take 4. 12 you take? No, it's not possible. 5 you can take? No, it's not possible. 1, if I take 3, is not possible, right? Yes, correct. So this is also correct only. So we did correct or not? 15. Yes, correct only. Which number you take? Tell me, student. 1 is not possible. 2 is if you possible, no. 3 is if possible or not? Yes, possible. You can see Y2 you can take 3. 3 into 3 is 9. When divided by 4, what is the remainder? You can see when you take 9, we divide by 4. 2 times 4 is 8. The remainder is 1. So therefore, suitable Y is 3. The same way, you can third things. Ni here. Okay, 1 minute. What is Ni? 12, right? 12 modulo. What is N3? What is N3? 5, right? 5. So how to write this one? Which number you can choose for it? Congruent to, when you divided by 5, so 2 times 5 is 10. Therefore, the remainder is 2 you can write, right? The 12 is congruent to, identically equal to 2, right? Then you replace here. 2 times Y3 is congruent to 1 modulo 5 you can write. So which number you can take Y3 such that when divided by 5 you will get remainder 1. So let us take 1 not possible, 2 if you take not possible, 3 if you take yes possible, Y3 you can take. So 3. So 2 into 3 is what? 6. 6 divided by 5 it's 1. So Y3 also here is 3, right? Yes, correct only, right? Yes, Y3 here is 3. All of you got it? Okay, so we found, finally we have to find the x value here. X here is, what is that? N1 you multiply with what is that? A1 N1 and Y1, right? Then you can see next A2 N2 Y2 plus A3 N3 Y3. These are the solutions. Okay, the proof is there in the Chinese remainder theorem. If you have a time is there, we'll discuss about the proof how this solutions is coming, right? Okay, so x is equal to, how to write? A1 is what? A1 here you can see, you can see here A1 is 2, 3, 1. Let us take 2, here is 3, here is 1. Okay, N1 3, 4, 5. N1 is not required, no? N1 here is capital N1 only, right? What is capital N1? 20, 15, 12, 20, 20, sorry. So 20, 15 and 12. What is y1 here? The first one you can see, the first one y1 is 2. So 2, here is y2 here is what? 3, here also 3. So you can x is equal to, how to write? So 40 into 2 is what? 80. So here is 15 into 9. So 15 into 9 is what? 135, right? Check it once. Yes, correct. 135 plus 12 into 3, 36, right? So 15 is correct only. So you can calculate quickly. So 135 is 36, 80 and 36. How much it will be? 1. Here 1 is there. 4 and 12. 12 plus 3 is 12 plus 15. 251 is there, right? 251. So we need to calculate for the unique solutions modulo capital N, right? So therefore it's modulo capital N, right? So x is congruent to 251, right? Modulo N here is 60, right? So you have to divide it. 251 divided by 60, you can do it. 4 times 60 is what? 240. Is so 11, right? You can see the 11 is the remainder. What is the 11 is the remainder, right? Yes, correct. Therefore, x is congruent to 11 modulo 60 is your answer. So when you take, understand this one, when you take the unique solutions, right? It should be for the modulo n, not modulo small n. The n is what? The product of small n's, right? So that only satisfies all the congruency. That's why we are taking the product of all the small ni, right? So the suitable 11, the suitable x value is what? 11 is the suitable for this all the congruency. If you put here, you can see in the question, if you put 11, so 11 when you divide by 3, so how much? You can see, you can verify this. 11 you put here, when you divide by 3, what will get? So 9. So the remainder is what? So what is 2, right? So when you take 11, when you divide by, when you 11 divided by, so when 3, so what is that? 3 times 3 you can take. This, I did wrong, I think. Oh, 3, that is correct, right? So here is 11 divided by 3 is 11. When you see, you will get remainder is 2 is correct. When you take 11 divided by 4, you take, what is the remainder? 8. The remainder is 3, right? Let's take 11 divided by 5. The 2 times 5 is 10. The remainder is 1. I hope everyone understand this one. So we need to find the unique x value satisfies all the congruencies simultaneously. If that x should be satisfies all the things, that is the Chinese remainder theorem. How to find the x value here? So x value, can see x value, how to find out a1, you know the remainders. N1, how to calculate? N1 here, that is this N1. So N2 here is what? Capital N divided by small n2. N3 is capital N by small n3. So you can multiply all the things and add it. You will get the 251 is the remainder. When you divide it by n here is the product of ni, that is 60. You will get remainder is 11. So therefore, the 11 is the unique solution, satisfies all the congruency, 3 congruencies there. No, that is the unique solutions for the system. I hope everyone understand. So you can watch this video. The coming days, I will post you more number of videos for number theory chapter, right? So if you not yet subscribe my channel, please subscribe it. It will help you for you in your IVOCM, right? So thank you everyone.